base, acid and base give you the salt. This is the stronger side of a tug of war, the stronger will win. A basic salt. Now, it's very important to know whether it's acidic or basic because it will tell you the pH. Acidic is below 7. Basic is above 7. So therefore, you see the titration graph. This is a strong base, pH above 7. X-axis represents the point of neutralization. Step number 3 here, this is called maximum buffer capacity. Now, maximum buffer capacity, this is the one that I will put it this way. We don't try to understand this. We remember it. Remember it is easier than understanding it. And so far, I never see any question ask you to explain it. So remember, remembering is easier. So what exactly is maximum buffer capacity when it takes place? There are two situations. I will give you the first version first because I need you to remember the first version. This version is what we call, let me just write down here for some space. First version is the most important. This is 80% of the questions. You have a conical flask here. Inside, you have weak acid plus maybe let's say weak acid or weak base. Now I'm going to add in a strong base. So the strong base is reacted with a weak acid or a strong acid added in reacted with a weak base. So this is two different scenarios. So remember, conical flask is weak acid or weak base. You add strong base, you add weak acid, or you add strong acid, you add weak base. Where does maximum buffer capacity take place? Maximum buffer capacity, I call it as MBC, will take place at always halfway of your neutralization point. Halfway of a neutralization point. Remember I said before, don't try to understand this. Remember this, it's easier and you know how to solve it. Later part, we will discuss this and you'll understand better. So we don't try to understand why this first, we use an approach to solve it first. Solving it is more important. So can we take a look at the graph again so you understand what it means? So let's come back to the graph here. Now in the graph here, just now in the question, we say that the conical flask is a weak acid. You're going to add a strong inside. Weak is in the conical flask, strong is in the B, right? You add it in. Your maximum buffer capacity is halfway your neutralization point. Halfway the neutralization point. This is neutralization point here, halfway. So for example, if this is 30, if this is 30, this will be 50. That is the meaning. Halfway neutralization point. Don't try to understand it, just remember it. Second, you need 2 points. One is the x-axis, one is the y-axis. Now the y-axis here is the pH value. So I need you to remember pH value is pH equals to pKa. Always pH equals to pKa. This is the first scenario, 80% of the questions. The second scenario. Now, second scenario has become a little bit more popular in school exam, a bit more popular. This is 20% of the time. This is a conical flask. Now the situation changed. You know what happened? Now, instead of having weak acid or weak base in the conical flask, now it's strong acid or strong base in the conical flask. Okay, so the situation swap, different. This is weak base and weak acid. So what will happen is I add weak base and weak acid into the reaction. So that means weak base, we have a strong acid, weak acid, we have a strong base. So the situation swap. I don't think they are the same, they are different. One example is, this is a man caught a girl. This is the other way around, a girl caught a man. Very, very different story. So what is happening here is maximum buffer capacity. It's not half, it's twice the neutralization point. Only 2 scenarios, no more. This is the two finite permutation they can ask you. Only two finite permutation, 2 times neutralization point. So make sure you record down these two. First version, second version, 80% of the question is this one. 20% is this. Okay, there are two versions. Later we will take a look at both of them also. So right now we're using this one because the weak acid is in the conical flux. Okay, so it's halfway a neutralization point. But the good thing is both of them is pH equal to pK for the y-axis. Okay, both of them are the same. Only this is different. These represent your buffer, which represent the banana. Remember, I eat banana. The banana represent buffer, is maximum buffer capacity. Two different situations. After which, we have one more. The everyday, which is the I eat banana every day, the everyday is the ending point. Now, the ending point, you must find out what is the excess amount of acid and base.